Hello everyone, welcome to my channel Siksha Deep. Today I am going to teach you the chapter Electric Current and its Effect of class 7th. This is completely based on CBSE syllabus. Chapter you will learn symbols of electric components, closed and open circuit, heating effects of electric current, electric fuse, magnetic effect of electric current, electromagnet, electric bell. So let's get started. You are already aware about how to make an electric circuit. You already learned in your previous classes how to make an electric circuit. This is a fun you can make by yourself. You can take a cell and you can take a cell, a bulb and a switch and wire and then connect them. Connect the one wire with the positive terminal and the other wire to the negative terminal and then connect it like the circuit which is shown here. And you already learned about how to make a connection in class 6, so I hope you can do this. Symbols of electric components, as you saw in the previous slide, about the circuit diagram. So while making a circuit diagram, you should keep in mind the symbols of electric components which you will use to make a circuit diagram. So you cannot every time for making a circuit diagram, you cannot always make a cell, bulb, switch, wire. So we use symbols in spite of that. So for cell, the symbol is like this way. Here you can see a big line, big thin line and a small thick line is there. So the thin line represents the positive terminal and the thick line represents the negative terminal. Then here this symbol represents the bulb. This is the switch, and when this line is like this way, it is in the off position, and when this line is connected to these two dots straight, then it is in the on position. Here wire or cable you can represent with a single line. You can make this single line of any color. Here is the battery. The battery is actually the connection of two or more cell. When two or more cells are connected to each other, that is battery. So what will be the symbol of that? This is one cell, this is the another cell. You can join some more cells to make a battery. So this way the battery are made. This is another kind of battery which are used in truck and tractor. I'll tell you about it later on. But these are the symbols of the electric components which you should keep in your mind while making an electric circuit diagram. Without these symbols, it will be very difficult for you to make it. So keep in mind these things. What is battery? Combination of two or more cell is called battery. A cell holder can be used to make battery of two or more electric cells. Here you can see that cells, how the cells are connected actually. This you should know how to connect all the cells to make a battery. This is the positive terminal. Connect a wire from the positive terminal of one cell to the negative terminal of the another cell. Then again one another wire from the positive terminal of second cell to the negative terminal of third cell. Now another wire from the positive terminal of third cell to the negative terminal of the fourth cell, and one more wire will get connected from the positive terminal and here from the negative terminal. Now if you will make the connection like this way, the connection will be proper and your bulb will glow, or for whichever purpose you are using, it will work. Now in many places we in our daily work, like in many places we use cell holders. These cell holders, we can hold the cells, we can add the cells in that to make battery of two or more electric cells. Now you might have seen this is there in a remote also. Two or more cells are there, as cell holder is there, torch you can see that. So these are used in these places. Tractor and inverter batteries. As I showed you in the previous slide also, that a big battery is used in truck, tractor, and inverters. How these batteries are different from the one which we made from the cells. Truck and tractor batteries are rechargeable batteries. We can recharge it, which supplies electrical current to our motor vehicle. Its main purpose is to provide current to the starter to start the engine. So this way the batteries which are used in truck and tractors are like that, whereas an inverter batteries provide small amount of current consistently for a longer duration of time. These inverter battery, truck and tractor all are rechargeable batteries. So this way they are different from the cells or the normal batteries which we make from the cells. Closed and open circuit. Now here you have to pay attention about closed and open circuit. How what are closed and open circuit? If you see open circuit, when no current pass through any part of the circuit, then it is open circuit. If you see in this image, you can see that the wire is connected from the positive terminal of the cell and one wire get connected to the negative terminal of the cell. But you can see that here the connection is not made. Here the switch is in the off position. As I already told you what is off and on of the switch, how the symbols look. So here in this you can see that the switch is in off position. It means the current is not flowing. The current is not flowing, due to which this is called as open circuit. In this case the bulb will not glow. In closed circuit, when current can flow throughout the circuit instantly, like here if you will see positive terminal is connected to the positive terminal is connected to the another terminal of the bulb, and here the negative terminal of the cell is connected to the another terminal of a bulb. Now here the switch is in the on position. You can see the symbol, the switch is in the on position. Now here the current is flowing very nicely. Flow of current is very nice, so that's why this is called as closed circuit. In closed circuit always the bulb will glow, but this won't happen in the open circuit. Effects of electric current. If you made an electric the circuit with a bulb, cell and wires, if you will notice when you make the connection, after making the connection, if you keep the switch on for few minutes, like 1 minute or 2 minutes, after that, after switching it off, if you will touch the bulb, it will be hot. You will observe that it is hot. So we can do an experiment also. We can check this. You can take two nails here and a nichrome wire and connect it with a cable, a cell and a switch. When you will switch it on, you will see that the nichrome wire get heated up, get hot when the electric current pass through it. Okay, you can observe this by carefully touching a bulb which was connected to a cell for a minute. Touch it after the switch is off. You will see that, you will observe that these all things are hot. This nichrome wire is hot and it is glowing. The bulb gets hot when you will touch it. So this is actually the heating effect of electric current. Now how we use in actual life this heating effect of electric current. This is called heating effect of electric current. Some examples, uh, these electrical appliances contain coil of wire which is called element. So what happen? These electrical appliances, the thing which get hot or which radiate the heat, they get so much hot, they get too much hot that sometimes it starts glowing. So these contain some electrical appliances which is called element, and these elements are present in these things which get hot. The element of bulb gets heated to such a high temperature that it starts glowing. Like if you will see this immersion rods, this immersion rods are used for heating the water. In this also this element is present, and when we switch it on, this element get hot, due to which our water get heated up. Now here you can see iron. In iron also elements are present which get hot, due to which we can iron our clothes. Now here this is the electric heater which are used in house to make the room warm. So in this also you can see that the element started glowing. So it depends what material we are using. So in all these electrical appliances, these elements are present. Now, the amount of heat produced in a wire depends on its thickness, length, and material. So, whatever your work is, like if you want it to glow or if you just want it to get warm, so it depends upon these things, thickness, length, and material. These are very important for whatever thing you want to make. Electric fuse. So this heating property we use, this heating property of this heating effect of the electric current we use in electric fuse also. If you will see in this picture, nail is there and a steel wool. You can take steel wool. This steel wools are present. You can use this for actually these are used in kitchens for washing the utensils. So you can take a small thin strip of that, tie it to the two nails, use battery, otherwise it will not burn. We need to have to do this activity. It is connected to the battery, a switch is there and a cable. You will observe that when it is connected to the battery, this will start glowing, and after glowing this will break. Broken steel wool, now it broke due to the when the electricity was given to it, it got so much heat that it broke from in between. Wire made from special material melt quickly and breaks when large electric current passes through it. These types of wire are used to make electric fuse. Now, electric fuse are used in many electrical appliances. Fuse is a safety device which prevents damage to electrical circuits and possible fires from short circuit current. Now, short circuit happens, so these electric fuse are used in house, schools, homes, and many electrical appliances also to prevent the short circuit and fire. Electric fuses are used in buildings, house, schools, electrical appliances. If you will see here in this picture, this is a fuse which are used in schools, buildings and all. And this is a fuse. It is called as MCB, miniature circuit breaker, which are used in our house and buildings. These are used in schools also. So they contain a element which breaks easily whenever there is a short circuit and all, to prevent burning, to prevent fire. So, and to prevent your electrical appliances from damaging. Short circuit. How does the short circuit happen? Short circuits happen due to few reasons. Due to excessive current in the electrical circuits. Whenever there is excessive current in the electrical circuits, the short circuit happens. Now, you will think that how the excessive current is there. The direct touching of wires, this happen if the insulation on the wire has come off due to wear and tear. When the two wires, they both the wire are in direct touch, at that time the excessive current flows and there is a short circuit. Connection of many devices to a single socket. This may cause overload in the circuit. Whenever there is a lot of devices are connected to a single socket, that due to the overload also a short circuit happens. So for preventing these things, always fuse is there to prevent the fire or any kind of damages. Magnetic effect of electric current. If you will, we previously read about the heating effects of electric current, and we used that effect of electric current for making some gadgets we make some gadgets and we made an electric fuse. So we use that thing. Now here is the magnetic effect of electric current. Now how the electric current shows magnetic behavior and how we use it. We use it every day in our life. Now how it is done, actually you can do a experiment to see how the to see the magnetic effect of an electric current. You can make a connection like this way. You know that this is electric cell, switch, bulb, and here you can take a box, a matchbox you can take, and a compass is very much required. And when you will keep the compass in the matchbox and make the connection, you can wrap the wire or the cable around it. This way you can make the setup. Now when this switch is in off position, as you know the symbols, when you will switch on, at that time you will see that the current starts flowing through it. When the current starts flowing through it, the bulb will start glowing. And at that time, you will observe that the compass needle is fluctuating. It will keep on fluctuating. And before that, it was stable. When the electric current was switched off, at that time, it was stable. But when it was switched on, when the current started flowing through it, the needle started moving. The needle started fluctuating too much. So, why this happens? Due to the magnetic effect. When you can observe this by taking out this compass from this box. Take this compass out from this box and keep a magnet near the compass. You will see that still the compass needle will fluctuate. So this always fluctuate whenever there is a magnetic effect. Whenever there you keep a magnet near the compass or there is a magnetic effect, the compass will fluctuate. The compass needle get deflected when the current flows in a nearby wire. This phenomena of magnetic effect of electric current was first observed by a scientist, Hans Christian Ørsted. This magnetic effect of electric current are used in many electrical devices. Can you think any of it? There are many electrical devices around you where this magnetic effect of electric current, this behavior of electric current is used. First example is electromagnet. So if you might be already playing with magnets. Do you know that you can make magnets from electric current? You can just make like in this picture, if you will see, a nail is taken and a copper wire is connected to a battery. When there is a connection, you will see that the current will flow, and as the current is flowing through the nail, it will behave like an electromagnet. It will behave like a magnet, which is a temporary magnet. Obviously it's not a permanent magnet. And if you'll bring any kind of magnetic material towards it, it will attract. So this you can try, but don't keep the connection for so long, because this requires a lot of electricity, and the electromagnet weakens the cell quickly if it left connected. So these are the magnets that run on electricity. Electromagnets always run on electricity. They lose its magnetism as soon as the electric current is switched off. When you switch off the electric current, it will lose its magnetism. This nail will lose its magnetic property when the current is switched off. The strength of an electromagnet can easily be changed by changing the amount of electric current that flows through it. So you want a very the strength of the electromagnet depends, it changes. The electromagnets are used in the cranes also. You can see here to remove, these are used in the junkyard to remove all kinds of metal from the junk. So this also electric current is passed through it and it behaves like an electromagnet. So the strength varies. If you want less strength, pass less electric current, and if you want more strength, then you have to pass a large amount of electric current. Uses of electromagnets. These electromagnets are used in electric bells, buzzers, loudspeakers, headphones, transformers, and electric crane. Electric bell. Now we'll see that how we can use the magnetic behavior of an electric current. Here we'll make an electromagnet. We'll see how an electromagnet can be used. Electric cell, electric bell. Electric bells are used in many places, example schools, offices, etc. It has an electromagnet in it. So here is the picture of an electric bell, how it functions. You might already have seen an electric bell in your school. We uses the magnetic behavior of electric current in this the working of the electric bell. Firstly, we'll label. This is the gong. Here, this is the iron strip with a hammer. This is the iron piece with coil of wire. This is the iron piece with a coil of wire. The wire is wrapped around. Next is the screw, and this you already know that cell, or you can connect a battery also, and this is the switch. Now how does this happen? How an electric bell works? In this, you can see that whenever this screw is in contact here, then the current flows through it. When the current flows through it, when the current flows through this iron piece, then it makes it as electromagnet, and when this behaves an electromagnet, it attracts this iron strip towards it, and when this iron strip get attracted, the hammer at the end of the iron strip bang the gong, hit the gong, it strikes on it. So when it strikes on it, the connection is loose from this, and when the connection is loose, the circuit is not getting complete. When the circuit is, if the circuit is not complete, so what will happen? It will not behave as an electromagnet, it will no more behave as an electromagnet, and then again this stripe will come back in its original position, and when this comes back in its original position, it will get contact with the screw, the circuit will be complete, the current will flow, this will behave like an electromagnet. When this will behave like an electromagnet, it will attract this iron strip, and the hammer at the end of the iron strip will strike the gong, and then again it will lose the contact with the screw. So this cycle will go on, and this is so fast that it strikes very fastly. So this whole process is very fast. So this way an electric bell work, and you can also make an electric bell of your own in your house by this way. When the hammer strikes the gong every time the circuit is complete. So this you have to keep in mind. You can make an electric bell at home by the help of this picture. You can make your own electric bell and use battery instead of cell. Don't use a cell. So in this chapter you learned about the heating effect as well as the magnetic effect of electric current, and how we use those behaviors of electric current in our daily life. So I hope you learned a lot in this chapter. If you liked this video, then please like, share and subscribe. Thank you so much.